Hi, this is Ed Kohler with Extreme Networks, and we're back with our fourth video in the series of setting up and enabling a Fabric Connect node and its associated services. As you will recall, in the first video, we set up and enabled a Fabric Connect node and ran a few basic commands to show the fact that, yes, we were attached to the fabric. The second video, we went a little bit deeper and showed some various commands to get familiar with the command prompt and what it means to look at a Fabric Connect installed node. And then we followed through with the third video, which was a bit of a deep dive into the link state database that's generated by the various ISIS type link values that are used to support the Fabric Connect environment from a protocol architecture perspective. We kind of went through the various TLVs, understood what they were and how they worked. We understood the fact that TLV 144 sub TLV 3 represents layer 2 virtual service networks, the ISIDs that we'll be working with. And then secondarily, we understood how to read it and walk through the database. Now that gives us enough foundational knowledge to actually start to provision layer 2 virtual service networks and layer 3 virtual service networks, because we understand what these elements are. But before we begin, let's just review what the definition of an L2 VSN is. An L2 VSN is a real simple thing. It's nothing more than a VLAN that's associated with an ISID. And it's the ISID that provides the constrained replication domain to support really what, in all intents and purposes, is flood and broadcast emulation. Because we don't flood within the fabric. We use something called tandem replication. And that touched on those multicast addresses that we talked about in the second video with the show commands. Now, as a result of this, the customer or client MAC learning is facilitated as an edge function of the fabric. There is no learning within the core. We really just provide the ability to transmit learning through this tandem replication. As a result of this, MAC learning is a very localized phenomenon that is kind of limited to the service element itself, and that's a good thing. It's a good thing for a couple things. First of all, it gives vast amount of scale to how large a layer 2 domain can be. Within Fabric Connect, we have customers that extend these fabrics through railways, transit networks, and they have no problem with scale, whereas in a traditional Ethernet VLAN extension, you'd quickly run into issues. So that's one nice aspect. But the other aspect is security. When you look at it, it becomes very difficult to poison ARP or spoof ARP because the MAC address learning is very, very localized. It's not a global phenomenon in whatever way or form. So there's a couple security aspects to it. And the best way I like customers to think about it when I have them in class is to think about Fabric Connect as a black hole. And in the middle, in the black hole, you have nothing more than BMACs and ISIDs. And those are your forwarding values, and they all occur at the 802.1 AH frame level. The edge of the network you could equate to the user-to-network interface out to the VLANs and users and things of that nature. That could be equated to an event horizon for the black hole. So from the subscriber perspective, there's no visibility into what goes on in the network core. We have this orthogonal thing going on where the functions of the core are indeed divided and separate from the subscriber visibility and the subscriber interface. So these are important principles that we need to remember as we move forward because Fabric Connect, as we talked about in our previous video, does not work in the traditional IP routed domain perspective. Now, an L2 VSN is a simple element, but it is also available in various service forms. There are four, and we're going to focus on one here. I tried to fit multiples in, but we're easily going to get out to 45 minutes in length, and that was way too long. So what we're going to do is we're going to focus on the CVLAN or the customer VLAN, the client VLAN, normal subscriber interface. And that's really nothing more than a mapping of the ISID to the VLAN. There are three other classes that are there as well, and we may have some separate videos towards the end of the series on these. Switched UNI, very handy tool, allows a switched VID function to the ISID locally within an element. And what I mean by that is that let's say I have a network element and I'm taking in two customers or two clients, And both of them are giving me VLAN 10. But I want VLAN 10 from customer A to go to ISID 1000, and I want VLAN 10 from customer B to go to ISID 1001. Switched UNI is a very handy tool to make that happen. It's very useful in multi-tenant data centers or any multi-tenant environment for that matter. Transparent UNI is basically an open pipe. It's basically taking an ISID and associating it to a physical port. So there is no VID involved at all, and it's basically whatever goes in goes out. eTree service is an interesting service that creates a private VLAN, hub and spoke type behavior, and it actually corresponds to two separate ISIDs that actually make up the service. And these videos obviously will take time in themselves, so we're not going to focus on those. We're really going to focus on the CVLAN, the normal subscriber VLAN interface today. So here we are back at our lab, and a couple things I want to review is how the video is going to flow. We are going to be logged into an established console interface through switch 4, which is the switch that we've been working with. This is the new switch on the block, as it were. And what we're going to do is we're going to telnet over to switch number 2. And the reason why I want to do that is I want to illustrate the fact that I went into, prior to the video, switch number 2, and I enabled and set up VLAN 101, and I associated that VLAN with ISID 1001. And as you will recall, all of our ISIDs up until now have been even. This one is odd, and I'm doing it intentionally because what I want to do is I want to exercise the equal cost tree algorithm that I referred to earlier. ISID 1000 as well as ISID 2000, because of the fact that they are even, are taking the secondary BVID path, which we know through previous use of the ISIS SPBM unicast tree command that 4052, the secondary BVID, is going across switch number 3. Ergo, the primary 4051 is going over switch number 1. Now, we know that an odd ISID is going to follow the primary BVID, so what will happen is once we complete this exercise, we will see that the transit, the actual Ethernet switch transit for ISID 1001 will be via switch 1, not via switch 2. So it's by this odd even capability that we get a load balancing capability, and we can actually calculate and predict exactly how ISIDs are going to behave prior to provisioning them. That's actually kind of neat when you think about it. The other thing that I want you to realize is that multicast ISIDs do the same thing. And this gives us a native inherent load sharing for the multicast environment. Even though the ISIDs are incredibly dynamic trees in that scenario, and we'll save that for a later video as well, you will see that they do load balance very evenly across the fabric based on this basic theory. Now, once we're done with looking at switch 2, we will then come back and look at switch 4. And at that point, we will start to set up and provision VLAN 100 and VLAN 101, and we will associate VLAN 100 with ISID 1000 and VLAN 101 with ISID 1001. So we're really going to be moving between switch number 2 and switch number 4 in this specific exercise. So before we go any further, let's bring up our command line interface. And here we are at the login prompt. We will log into our switch. By the way, I have defaults here, probably not a good idea to maintain in a deployed environment. So let's go into our enable prompt. We have our hash indicator. And what I want to do now is I want to telnet to switch number 2. And we will log on to switch number 2 and go into the enabled prompt. And here I just want to do a show run command. And what this does is this will show us the running configuration that I have in the switch. And let's just move down through the services. We can see we have our boot flags. You can see my prompt command, largely empty. After all, this is a lab config. You can see I have my VRF configurations. We have 2 VRFs, one named VidServe, which is obviously for video surveillance, and then the secondary one, which is IPTV. We have our Ethernet interfaces, our SPBM information, note our nickname, our BBIDs, the fact that we're enabled with multicast and IP. And here's what I'm looking for. This is our VLAN configuration information. And here we have our VLAN 100, and it is associated with ISID 1000. And you can see that I created VLAN 101, and I've added ports 25 and 26, and I've taken 101 and added that to ISID 1001. So that's the primary gist of what I've done here. Couple things. You'll note that none of these VLANs have IP addresses, only the VLANs associated with VRFs. And let's move further on down the line. You'll see that I have 520 and 620. They have IP addresses, but they are associated with VRFs. And the reason why is because if I put IP addresses on the VLANs associated with L2 VSNs, they will show up in the GRT. I don't want that. And there's a reason why I don't want that, is because I want to have a separate plane of interest. Now, you might say, well, how do you get IP? Well, I run DHCP in that service. So you can see that I'm running through these L2 VSNs. The ones I'm actually configuring now, and you can see that my network interface is 168.1.4. And my gateway, you can also see that I've got a public domain. My DNS suffix is rochester.rr.com. That's Roadrunner. That's Spectrum. So, okay, I can have separate IP environments. I don't need to have that. And that becomes really neat. These L2 VSNs are dark because when I did the show IP routes, and actually if I do any type of show IP information within the fabric, you will not see 192.168.1. You will also not see 192.168.0, which is my primary gateway out to the public world. So that's all good, guys. And these are standard Class C addresses that are used by various folk. But as you can see, I don't have really any need to have IP services within the L2 VSNs themselves. I can do quite fine with just the local DHCP services, and I'm either doing that through actually one side is done with a firewall, and then the further upstream one is done by my normal residential gateway. Now, there's a couple things here that are convenient about that, is I have this dark addressing space that you can't see from the fabric, but more importantly, from those addresses, from my residence, you can't get to my lab. It's totally separate. There is no way that there is any connectivity into my lab environment. And actually, if I bring this back up again, we can validate that by trying to ping to 10.0.0.2. And we can see that I'm going to fail. There is no connectivity. And the reason why is because these L2 VSNs provide me a different service plane of access, and that's all controlled by my security demarcation and also my residential gateway. So it's all neat because now I've got these two networks that are ships in the night from one another, and I can do what I want within my lab environment, and I know that none of these 10 nets will be visible or accessible to the outside world. Okay, so we've looked enough at what we've done within the VLANs. Before we move back across, though, I just want to show a couple commands that are nice to know about. The first one is show VLAN ISID. And this will give me a list of all my ISIDs that I have configured. I'm running it from this side because there's really nothing running on the switch number 4 yet. So you can see that we have 4 ISIDs. We have our management VLAN in ISID. We also have VLAN 100 with ISID 1000. We have VLAN 101 and ISID 1001, which are the two that we're going to work with in the exercise. You can also see my VLANs that I have associated with VRFs listed. And then, of course, we see our BBIDs, 4051 and 4052. Let's take another look at a command, which is within the VLAN module, to show our MAC address entries. And this time, let's look at 200. And the reason why we're looking at 200 is I know there's something on there right now. 100 and 101 really don't have anything running. And there we go. We show that we have a locally learned MAC address, and the tunnel interface is switch number 1. And we can look at that further, and we can see that we have a population of the table giving us our MAC address, the destination MAC, across the network, and the fact that, again, this validates switch 1, and the fact that the status is learned. So that's about as much time as I want to spend on switch number 2. Let's exit the interface now, and that will take us back to switch 4. So now we're back at switch 4, and our goal is we want to create some VLANs here. So the first thing we need to do is go into our config T, and now we want to create a VLAN, and we'll use the create command, and we will create 100, and the type will be MSTP, RSTP, and I believe I need a port up in front of this. And we'll define it as a group of 1. Okay, and now we're ready to add our VLAN members. And let's see. We'll go with 12 to 24. And let's just, for proper practice, remove them from 1, which is where they would be resident normally. So now we have our VLAN created. We have our VLAN members. If I wanted to set an IP, I could go into the interface VLAN command, and there I can set the IP address. But as I've said, I don't do that as a normal practice. I run DHCP inside the L2 VSN environments. And to me, that's a critical differentiator. It makes a difference from a security perspective, keeps me in a separate service plane, and it also keeps my residents and the rest of the world from my lab environment. And that's I think, a very strong benefit. And we're not talking a firewall interface between these environments. They're truly orthogonal. There is no connectivity between them whatsoever. So I can rest at night knowing that no one's going to be able to get into my private lab environment from the residential side of my network. Okay, so now that we have this, the next thing we want to do is we want to take this VLAN and we want to associate it with an ISID, and we want to do that to ISID 1000. And the command is very simple. We just say VLAN space ISID, then we specify our VLAN number, and then we specify our ISID number. We have just created an L2 VSN. And it's that easy. Now, the next thing we're going to do is we are going to create VLAN 101. Once we do that, we will add some members. And this time, we will pick 2 ports, 25 and 26. And we'll remove from 1 as well, which again is, I could bypass this being a lab environment, but I'm just showing you proper practice here. So we'll take 125 and 126 and get them off of 1. So now we have a VLAN created that's 101. We have 2 members, ports number 25 and 26. And now we want to take that VLAN and we want to associate it with an ISID. And 101, as we indicated, will be associated with 1001. Okay, that's it. Our exercise is complete. So we're done. What I'm going to do is do some show commands. So let's do a show on the VLAN ISID table here. You can see that we have our VLANs and ISIDs set up. Now I want to do a show on the ISIS link state database, TLV 144 detail, and let's see what we see this time on our switch. Okay, so now we're all the way to the bottom of our screen, and we see our entry for switch number 4. We see our LSP ID entry for ISIDs, and we're going to be looking at L2 VSN information. on type length value 144 sub TLV3. There is our update, our triggered update ISIDs. We also see that we have 2 ISIDs set up. And on 4052, we see that 1000 is indeed taking the primary path. And 1001 is not. And the reverse is true for VLAN 4051. We can see that that traverses over 4051, so we know that we have the divergent service paths that we predicted at the outset of the video. So that's pretty much it. Again, the only thing that we're missing here is if you wanted to have IP addresses on the VLANs, at that point you go into interface VLAN and then specify IP address in the command that you want to set with the appropriate IP address and mask, and you can get them set up. I do not recommend that as a general practice. I prefer to run DHCP services inside the L2 VSNs, and that gives me this dark dynamic environment where I keep an orthogonal service plane from the actual switches themselves. There's no way that I can get to that environment. So that's pretty much it. Thank you for your time.